So I'm just trying to get the slides posted in the meetup here, and I'm on like a computer that I don't normally use, and so I'm not actually logged in the meetup, and I don't know my password. So this is going really, really well tonight. Just like hoping this is like we're going to get all the bugs out at the very beginning here.
Is it easier just to type in the URL into mine?
Well, maybe. Let's see. No, it is not easier to type the URL.
Can you email it to me?
Give me a sec here. I'm just gonna log in. I can get the password. It's just gonna take me a second.
Oh yeah. This is almost certainly the worst idea we could come up with. Oh yeah, there's a screencast. You just gotta roll with it. Enjoy the pizza, the drinks. Go grab some more. I think there's plenty. I'm gonna grab some. You don't control which thing to try.
Okay, so I posted the link to the slides. Can everyone try to open them up and make sure you can actually see them and I haven't screwed up the sharing in some way? Okay, cool. Yeah, exactly. I actually, I'm sort of wishing that I had like an overhead projector, like one of those with a marker I could write on. That would make me feel really awesome and retro right now. Okay, so I'm going to get started. I'm kind of going to, I have this wonderful like whiteboard. I might actually use it. But I'm going to just sort of assume that I'm just going to sort of assume that you're like following along with the slides. I will try and let you know like where I'm at. Now you can see all my notes. Please don't read them because it's going to spoil all of the jokes. But all right, so welcome to Exploring Source Maps. And I didn't have time to come up with a subtitle, so we've got my witty subtitle joke. But let me tell you a little about who I am. So my name is James Kruth, which you already knew. I've been coming to SemJS for probably about, I don't know, maybe about 2 or 3 years now. And I've given a couple of talks, all lightning talks. This is my first sort of like long form talk here, and so I'm super excited. Naturally, like everything broke when I decided to actually give a longer talk. I was kind of expecting it. I own a software consulting firm. I'm always like looking for work, contract work, consulting work, and so just put a plug out there. It's called Ars Mentis, custom software. I mostly work for startups, but some other bigger companies as well. And I do web apps, mobile apps, that sort of thing. That's sort of like my day job. I have a lot of JavaScript experience. I've been programming JavaScript for like more than 20 years, which basically means like if you went to Stack Overflow on April 1st, like I was like, oh, it's my web page from 20 years ago. Yeah, I've done cursor trails. Like I did like little pop-up windows that would show images when you clicked on them and stuff, and all of the horrible things that you'd never want to do today. I did all of those things. So here I'm just coming clean right now about all of that stuff. I'm also like really interested in the esoteric corners of developer tools. I've done a lot of work with developer tools and like how sort of like people develop software, and so that's kind of part of how this talk was born today. Is I started thinking, no one really talks about source maps, and so I decided to start digging. Please follow me on Twitter and Mastodon if you want to hear a little bit about JavaScript and a lot about retro computers and rock climbing. Like that's mostly what I tweet about, but I do talk about JavaScript and programming a bit too. So I'm going to start with a bunch of slides that are really super visual, so this will be fun. So you've probably seen source maps before, and if you happen to look at your slide and you click through it, because there's a lot of click things, unless you're viewing them in the viewer, I don't know what you're looking at. I'm just going to hope. So you've probably seen this file, this JSON file. It's just full of like all of like these letters, these groups, commas, semicolons, and if you're anything like me, you were like, what are these things? Like, how do these even work? I don't understand. And so I was just wondering, what do these things even do? And I know everyone in here has also seen some minified JavaScript before. And so source maps are this wonderful thing that turned minified JavaScript, the mess of minified JavaScript we were dealing with for years, into nice, clean JavaScript. And so on top of it, source maps also work with things like the built-in debugging tools, and they're enabled by default in modern browsers. A lot of developers actually aren't aware of that because they've been doing this stuff for so long and have been changing their settings back and forth for so long. But if you open up any modern browser, its default settings, source maps just work. And they allow you to, instead of looking at like this giant mess of minified JavaScript, you can see nice source code that was written by a human. So this is pretty useful, and I think that we can all agree that source maps are awesome, and we love source maps, yay! And that would kind of be the end of my talk, except I think Ian might be a little upset with me. And so there's a little more of a story here. So I want to tell you about my story first and how I actually ended up learning about source maps. So a long time ago, in a Slack channel far, far away, I was talking with some security people about JavaScript. Now, it's always kind of a questionable idea to talk with security people about JavaScript, because as you might have heard, JavaScript is a privacy-destroying abomination of a language that should be killed with fire. If you weren't aware of that, I'm happy to educate you. Now, we all started talking about tools like NoScript, tools to make sure that at least when you run JavaScript, you can only run the JavaScript you want to run. But, so who out here has heard of NoScript? Okay, so a few of you have heard of NoScript, including some of the security people sitting right over there. Okay, so if just raise your hands again, please, if you've heard of it. Okay, now who thinks it's easy to use? Okay, so we've got one person who's in the easy to use camp, and everyone else, their hands just went down like this. And so I don't like NoScript either. Like, it is a tool, it gets the job done, but it's not something that I'm gonna like inflict on anyone but myself. And I started thinking there's gotta be an easier way to use this tool. And so I promise this isn't like a startup pitch or anything, first of all. Like, I'm not about to like pitch like NoScript.io to you or something like that. I'm just suggesting that, and I'm not gonna suggest either, that we're gonna put NoScript on a blockchain or incorporate AI or any of those things. That's, no. But I started to think it'd be cool if we could just encapsulate a few like simple heuristics. Things would be like, hey, you know, it'd be nice if NoScript was smart enough to know, like, oh, I don't know, like what could we say? Like, what was possible, you know? Maybe is a JavaScript on a CDN or not? Do we trust that JavaScript? I started talking to a lot of people in this Slack channel, and they promptly told me, no, that's impossible. You can't do that. Which is oddly heard very often in security chat, Slack. I don't really understand why. And so people are, you know, telling me, yo, you can't do that. No, it'll never work, you know. And I thought to myself, this is how most of the things that I end up spending way too much time on start out. Is that someone says, no, there's no way you can possibly do that. And so I started thinking about ways, just simple ways to whitelist JavaScript. Like things like, you know, does it come from the domain of the site I'm actually on? Like, maybe I trust that at least a little bit. You know, I mean, like if I'm on, you know, like coolretrocomputers.com and I go get some JavaScript from them, I probably at least trust that a little bit if I trust the people running the site. You know, does it come from a known CDN? Is it a known library? Is it minified or obfuscated in some way? You know, that would be an indication that maybe I should be careful with that code. And then I got to the interesting one. If so, does it have a source map? I started thinking about this. I started wondering if I could actually look at source maps and figure out some way to use them to kind of go backwards and see if the obfuscated or minified code actually was what the source map was talking about. Like, how much of the minified code is not represented in the source map? And then I started to wonder, could I make source maps do evil things? Like, could they hide code? Like, could I put a Bitcoin miner inside of some code and then hide it with a source map? And I realized that I needed to learn a little more about source maps at this point. And so I decided, okay, I'm going to go back to the very beginning of this. I'm going to go back to the beginning. I'm going to go back to the dark ages. That is otherwise known as 2009, when we had a couple tools for debugging JavaScript. You know, Firebug had been around for a little while at that point. But for a lot of us, debugging mostly looked like alert and console log. Now, I haven't written an alerts statement in a really, really long time. But I still use console log kind of in an embarrassing amount of time. Is that this hit a little close to home. And it got me thinking about some other problems I used to have back in 2009. Like when I would get a minified JavaScript file, and I'd want to use Firebug on it, how do I set a breakpoint on a 32 kilobyte line? Like, that's just not, I mean, like I would be like, oh, I'm breaking on what, the entire line? I don't know. And so for years we were just wandering in darkness. You know, I was like addicted to back alley JavaScript source code formatters. I mean, it was a bad story all around. But little did we know, in 2009, internally at Google, a document was being written. Now fast forward to 2011, and suddenly a light appeared in the darkness. A Google Doc started making the rounds, and people took some notice of this. This was the first time that most people had seen something like source maps. And this was actually when the source map revision 3 proposal was released. And so finally, once again, we're all thinking, yay, I love source maps. Source maps are great. This was the answer to all of our problems. But then I took a look at a source map and I was like, wait, what? What is this thing? Like, so, I mean, this is the thing. I've been looking at files and formats and all this stuff for a long time, figuring stuff out. But I look at this and this thing just, I was like, I don't get this. I wasn't sure what was going on. You know, and I thought, oh, maybe I can just, you know, figure it out. Let me look at, like, maybe these letters will make sense if I just, like, look at them, like, maybe they're base 64, maybe there's something else going on. I couldn't figure out what was happening there. And set it aside, and for years I kept on thinking, I'd look at the source map, I'd be like, man, I really should figure out what that's all about. But it stayed that way for years until now. And so let me start with the easy question at least. What is up with this spec? And this, I'm actually really sad that this slide isn't working because I managed to make not only a blink but a marquee simulation in this slide. I worked really hard on this. You have no idea, like making the rainbow text.
I see it.
Okay, good. I'm glad some people are enjoying it here. Good, good. And so the fact is that there's not actually really a source map spec. Like, this is one of the weird things about source maps, is it's just a Google Doc. It was this internal thing at Google that Google was like, yeah, we'll just put this out there and see if people use it. A lot like blink and marquee tags. Like, just like something that the browser vendor was like, yeah, maybe they'll use it, I don't know. And then everyone was like, oh, it's a standard. And that's exactly what happened with source maps. These are just a convention, but they're a powerful convention. They're a convention that we're all using today. So, oh, now I have to sit through my animations. See, I should have been clicking through this. Come on, there it goes. All right. So I want to start with the basics of what a source map is all about. So a source map is really just a JSON file. It contains a version. It's always version 3. You're never going to see anything that's not version 3, unless you're dealing with some really, really old code and it won't work in a browser. It optionally references a generated file. It optionally specifies a source root. It lists the names of the original sources. It optionally includes the content of the original sources. Now, this optionally on this is becoming less optional, at least as far as modern tooling is concerned. I don't think I've ever seen a Webpack source map without the original content in it. It includes a list of symbol names used by the mapping data. Finally, it includes the actual mapping data, all of those letters and numbers that I was talking about, or most of the letters that I was talking about. And it's referenced in the original file, or I'm sorry, the generated file, with a comment. Something that basically just looks like source mapping URL equals URL. So if you haven't seen this stuff before, it's pretty easy to see if you work with Webpack or Babel or Uglify or any number of tools out there for processing JavaScript. They all can generate source maps. It's very easy to generate your own source map and sort of play around with this a little bit just to see what these things look like. Now I have an example that no one can see, or at least almost, I mean, like, I guess everyone is following along at this point. So, but I want to point out some of the things about this example. Does everyone actually looking at something right now? Okay, cool, awesome. Do you have a question? No. Okay, cool, good, cool. So I want to point out a few things about this example. The first thing is that the sources that are listed in here don't actually have to point at real files. And again, if you look at what Webpack generates, they don't point at real files. They're just these opaque identifiers. They still have the real file name in them at some point because it would be just confusing to use like UUIDs or something. But they can be kind of whatever you want them to be. It's just something so that the browser can look at it and say, oh yeah, that's what that file was originally named. The sources content corresponds to entries in the sources list. And so we have a one-to-one relationship between these two lists. And you don't have to have sources content. It's actually not well defined what names is all about. The spec doesn't do a great job of defining it. There was a conversation on a Mozilla mailing list a few years ago, which also people were like, oh yeah, it's intentionally vague. We figured the browser vendors would figure out something to do with it later on, which is exactly how the rest of the spec sort of goes as well. There's some indication that it can be and is used to deobfuscate stack traces. And so if you got a stack trace with a bunch of generated variable names that mean nothing to you, the names can, and in some cases will, deobfuscate that. But I've seen some source map generators just not generate names at all. Sometimes they're generated and it seems like the browser just doesn't use them. And so it's a little bit of an odd thing in the specification that's not actually a specification. And then there's this mappings field. And by the way, I want to point out right away that in this example, which I took directly from the source map spec, this mapping example is like the weirdest thing ever. You will never see a mapping that looks like this. It is probably somewhere in the neighborhood of invalid. Like, don't look at this mapping example and think, after the talk, I'm going to decode this and see what it's all about, because it is a very, very strange example. In fact, it actually, well, I'll get to that in a little bit. But I wondered, what is going on with these mappings, especially after reading the spec and being like, this doesn't even seem right. Like, what's going on with these mappings? And so the one thing you need to understand is that source maps are actually meant to be really, really small. They aren't in practice because they contain all of the generated source code and a ton of mapping data. But especially in like 2009 computer speeds and times and browser speeds, source maps, even back then, were getting to be so big that they were causing problems to the point that they were almost unusable. Now, I'm sure that there are some people in this room who have dealt with some source map problems even today and have, especially in doing stuff with, maybe you're going like TypeScript to JavaScript and then compiling down to like ES5 and everything, you can end up with some pretty big source maps. But these source maps are meant to be small. And so a lot of what we see in source maps today is all about the idea of taking a simple idea and making it much, much more complicated so we can send it in fewer characters across a wire. They're not meant for humans to read, which is why I was kind of excited to give this talk. So I want to establish, first of all, what a map is all about. What's actually in a source map? We're going to start by sort of like designing our own version of source maps here, because it's actually a small enough specification we can do that over the course of the next half an hour or so, maybe not even that much time. And so what this means is basically that we're going to sit down and start just putting these things together, at least based on how we understand them. So a map is associated with one output file. A map is going to contain a number of entries mapping sections of that output file, one at a time, to sections of one or more input files. An entry is going to look something like this. It's going to have an output file starting row and column. It's going to have an output file ending row and column. It's going to have a source file name. It's going to have a source file starting row and column and a source file ending row and column. Now, if you look at this, this should make a decent amount of sense. All we're saying is that, and maybe I'll use a whiteboard just for sort of like the novelty of it. All we're going to say is we've got our output file over here, which is going to be like, and we're going to specifying one particular chunk of that output file. And we're taking that over to some input file. that looks something like this, not maybe nicely formatted source code, and we're saying, oh yeah, we were talking about this thing. So obviously we need a row and a starting column, a row and a row and an ending row and column. Same thing here, starting row and column, ending row and column. And so that's roughly all we need for a source map. In fact, that's really almost all the information a source map contains. And so I made up this little thing called Proto maps, which is basically what I just described. So I've already done a little bit of stuff that makes this maybe a little less friendly for humans, because I didn't label what was a row and a column in this list. And I'm assuming everyone's looking at the Proto maps example slide at this point. I'm going to be sort of leaning on the slides a little bit more, so let me know if anything seems confusing. I didn't label the starting row and column, the ending row. I just figured, well, we'll do like sort of like an XY type thing here. But everything else is basically just as I said, and this is basically the data you need to map from one file to another file. But this is a lot of information, and there's a lot of redundancy in this file. Like even if I'm just talking about redundancy in terms of like text stuff, well, we see start happens twice, end happens twice. You know, we've got these big words like compiled and source, which, you know, a computer doesn't need those things. And so how can we make this smaller? Well, we can make it slightly smaller by, instead of referencing the source file by name, or whoops, sorry, got a little off track there. We can get rid of endings. So whenever the first, like if I have a particular mapping like I've represented right here, whenever this particular mapping ends, we can say, well, the second mapping will begin. And so we can make some assumptions that say, well, the second mapping might look like this. And because we know what the start of this is, we don't really need to know what the end of this is. And the same thing can be done over here. I'm going to gloss over a few details, but assuming that things are in order, and to a certain extent, even if they aren't, you can again just say, well, if we end right here, we're going to start right here, and so the start of this is the same as the end of that. And so we actually don't need the endings. We can just knock those right out of there. So those are my slightly smaller proto maps. But we can do even better. We can actually not reference the file by name, because especially we have a bunch of mappings in there. We don't want to have foo.js in a file a ton of times. So instead we might just reference the file by number. And so now a mapping is looking like a dictionary with about 5 numbers in it. But we can go even further. We don't actually need the row number in the compiled entry as well. If we group each row of this output one at a time, so all of the groupings from all the mappings from row 1, and all the mappings from row 2, then all the mappings from row 3, then we can make it even smaller. And so on the incredible shrinking proto map slide, that's what I've done. So we've hit about the limit of what we can do in terms of readable optimization. But if we intend the format to be read by machines only, which is kind of how source maps evolved, we can make it much, much smaller. Take a look at the machine readable proto map slide. Now we've just said, okay, well, you know what? We're just going to have a list of 4 numbers. One is going to be the starting column. One's going to be the file number. The starting column of the output, the file number, source row, and the source column. And this is starting to look like the perfect thing for a machine to read. Now we're getting pretty close to the smallest obvious mappings. One thing to keep in mind is that the bigger a number, the more characters it takes to send across a wire. So if we have a number like 32,000, because this was apparently a giant, this is basically all the source code in the world that we've mapped at this point. And then we have 32,007, 32,012. As we have in this example, there's a lot of redundancy there. And we're sending, to represent that number, we're sending 1 byte per character at least. Unless we're using some crazy encoding like UTF-16, then it might be 2 bytes per character. And so we can start to get rid of even that redundancy by just storing relative references. So the first thing we store is 32,000. And then we store 7 and 5. And if you look on the slide here, can they get any smaller proto maps? Well, you can see that what has gone on here is that we're just saying, well, we started with 32,000, and then the next reference is plus 7. And then the reference after that is plus 5. And this is exactly how source maps do it. Every reference is a relative reference, except for the first one that establishes your position in the file. So this is pretty close on the can they get any smaller slide to what the version 2 spec looked like. It was not quite this, but it's close enough for the purposes of this talk. But even this was too big. We started looking at all of the data we'd have to send across the wire just for a simple source map, and it ended up being a lot of data. And so we tried to, there was an effort done to try and figure out, how can we make this even smaller? And so we ended up with this weird thing that I had never heard of before I read the spec called base 64 VLQs. Now, I'm just really curious at this point. Has anyone heard of VLQs outside of source maps in this room? Has anyone heard of VLQs at all? Okay, this is super awesome. I'm glad I get to talk about this tonight. I'm going to educate all of you on this super esoteric thing that you'll never use anywhere else. So this is really exciting. I mean, and these things are kind of weird too. I really like weird low-level stuff. That's kind of my thing. But I'm going to gloss over a bunch of stuff too, because otherwise I'd have to teach I don't know, maybe a whole computer science class, and I don't think we quite have time for that. But if you really want to have an in-depth discussion about numerical representation methods on digital computers, just hit me up after this and we can chat at the bar. It just normally when everyone else is talking about sports, that's what I talk about. So is it an acronym? It is an acronym. So VLQs actually stands for variable length quantities. So I just want to break this down. So we're going to start with base 64, which, okay, raise your hand if you heard of base 64 before. Okay, yes, awesome. I figured everyone here had. It's very, very common in JavaScript. If you haven't, there's a pretty solid Wikipedia article out there that I actually did reference a little bit for this. But basically, all the base 64 is about is taking data that you couldn't encode as characters, you couldn't encode as UTF-8, and encoding it as UTF-8. And you can store images this way, fonts this way, all sorts of stuff. And if you want to talk about base 64, just let me know, Ian. I'm free. Okay. So the important thing, and I included this table in the slide. This table is right off of the Wikipedia page. If you're following along, and I guess now everyone is, by almost sort of some stroke of luck here, you might want to go back and reference this table as I start going through and doing some stuff, because it'll be a little useful, and you'll be able to follow along a little bit better. So what about this VLQ stuff? Well, first I need to take just a tiny little detail into how numbers are stored on computers. So let's say I want to store the number 123 on a computer. And I'm gonna totally use the whiteboard again because I haven't used a whiteboard in a long time. I'm kind of digging this. So if I want to store the number 123 on a computer, like, there are a couple ways I can store that. There's actually a lot of ways I can store it. But one of the ways I can store it is just the characters 1, 2, and 3, which in binary would look like this. Yes, good. But I could also just store it as the number 123, which in binary looks like this. And so the observant listener will notice that one of these takes up way more space than the other one. And that's kind of the thing that the people who are working on source maps were looking at, is saying, you know, we're going to be sending numbers across the wire. Sending them like this is probably not great. We should probably send them as close to this as we possibly can. The problem being is that once you start getting into larger numbers, you can't send these using UTF-8. So we need to come up with some sort of a solution. On top of that, the numbers that we're dealing with source maps are all sorts of different sizes. Source maps say that you can have a number up to 32 bits, which is, this is just 8 bits right here. So the solution is this thing called variable length quantities. Now, I'm not going to lie to you, this took me a little while to figure out. Like, I spend a decent amount of time doing tinkering with like old school low level stuff, that bits and binary stuff and hexadecimal and all that stuff. And this was still just a little bit of a stretch for me at first. Like, it feels like really good now, but if you don't initially get this, don't feel bad, sort of let it sink in. And this is the main reason I kept on putting off figuring out the source map stuff, because this was just a little bit intimidating. So I have this wonderful slide of Bill Gates saying something that he never actually said. Now, the thing of it is that, when we're dealing with base 64, which that is part of all of this, we've only really got 6 bits to deal with. So not even 8 bits, just these 6 right over here. That's the way that base 64 stays, so it can be encoded using something like UTF-8 or ASCII. So if this isn't immediately obvious to you why this is, that's cool. Just trust me for right now. You can go off and read the Wikipedia article and learn a lot about base 64. But all you really need to know is that we've got 6 bits to work with. And in those 6 bits, we've got some boxes to fill in. So again, I'm going to kind of use the whiteboard unless people are not finding it helpful. Is this actually helping anyone, or am I just amusing myself? Okay, cool. So the deal is that when we start talking about sending values across the wire, we've got these 6 bits to work with. Well, I'm going to just number these. That doesn't work at all. Seven, 6, 5, 4, 3, 2, 1, 0, because we're all computer people here, and we all know that you start counting from 0. And we don't use these two because I said only 6 bits to work with, 0 through 5. So when we start talking about variable length quantities, we've got this 5th bit right here, which is special. This is the continue bit. And then we've got 5 more bits in which to store our data. And that's almost the entire story with VLQs, except for the fact that there's one tiny little part of the story I left out, and that is that when you've got a variable length quantity, it can be many of these little bit structures where this would be 0 or 1, 0 or 1, 0 or 1, 0 or 1, 0 or 1. But the first one always does something special with this first bit. If it's the first VLQ, instead of this being 0 or 1, this is a sign bit. Yeah, it's a little strange, trust me. And so it's a 1 if it's negative, or 0 if it's positive. And so the first time I saw this, I was like, okay, wait a second, guys. Can you tell me when I'm going to need to reference negative column numbers? Is that like a thing that I'm going to do? And it turns out that when all of the column and row numbers are relative, because we've done that to save size, if we need to jump around in the file, then you do actually need negative column and row numbers occasionally. It's not incredibly common. I've looked at a lot of source maps at this point, done some sort of analysis stuff. You don't see the negative numbers too often, but they do happen occasionally, especially if you got some wacky thing that has decided that it's going to move source code around as it's compiling it. So I've got an example here, and I think I'm going to try and walk through it on the board. So I want to talk about how we would store the numbers 37, which is binary 1, 0, 0, 1, 0, 1. All right, so the first thing I can say is that this number is a positive number, and so for our first VLQ, at least the sign bit is 0. Awesome. We also can see right from looking at this that the next 4 bits would be the first part of that number, but there's more bits there. And so the continue bit is going to be set to 1. We aren't going to use these. And then I just fill the rest of this in. But this isn't the entire number. I've still got these 2 bits over here I've got to do something with. And so I make another VLQ. This number actually means, well, I don't think it's technically another VLQ so much as it is the continuation of this. This technically needs 2 values to represent the entire number. And we don't use a sign bit in the second one. So we just fill in the rest of these numbers, 1, 0. So these bits don't get used, they just get all zeroed out. Finally, I can use any old binary calculator to turn these back into numbers. And so I end up with a 42 here, and a 2 here. And then I turn those using the base 64 table into letters, and this would be represented in a source map by the letters Q, C. Yay! So I'll do one more example just to drive it home. We'll do negative 14, so I can use that sign bit, because I've always wanted to look at column negative 14 in the file. Okay, so obviously in this case, the number is negative, so I'm going to set the sign bit to 1. And I should write the binary representation too, that's a good idea. And we've only got 4 bits here, and so there's not going to be a continuation, so I'm going to set this to 0, still won't use these. And then I'm just going to fill the bits in here. 1, 1, 1, 0. I'm going to turn this into a number again, which ends up being decimal 29, and then use the base 64 table to convert that into a lowercase d. That's how we would store negative 14. Okay, wow. That's a whole lot of stuff just to store some numbers. And I made a little cheat sheet for myself. And I've also got a couple handy websites available because honestly, after doing this manually once or twice, I was completely done with this. It's kind of fun to know, but this is definitely a job for computers. The cheat sheet is kind of interesting, actually. I just want to point out one thing about it. It's on the slide, VLQ Cheat Sheet. The interesting thing about it is that it turns out, because there's an explicit sign bit here, you can actually have a -0. And if you know anything about -0 and the history of computers and all this stuff, if I was looking for bugs in browsers and stuff like that, I'd probably start tossing -0s at source map parsers and just see what happens. You can't really get rid of the -0 using this representation, but it was a little surprising to me to see that. And on the cheat sheet, basically, it just walks through what some of the numbers for at least the first part of a VLQ might look like. And this is actually kind of useful when you're dealing with source maps. If you look at a source map, oftentimes the numbers in source maps are so small because they're relative that the continuations are rarely used. So if you know the first, the values for the first, say, like 32 possible VLQs, which is just the letters capital A through lowercase f in the base 64 table, you kind of can just look at source maps and say, oh, well, I know what number that is. It gets more complicated when you start seeing continuations in there, but at least you can spot them. And when you start seeing higher lowercase letters, you'll know there's probably continuation there. Now, there's a pretty cool website out there that actually will do a lot of decoding for you. I've referenced it on this slide, and there's a slide at the end of my talk. And there's actually, of course, because everything is on NPM, a library on NPM to decode VLQs as well. And it doesn't depend on left pad, so yes. There's still a question I had, though. After I went through all of this, why go to all of this trouble? Like, why is this such a, why are we doing this? And it turns out that VLQs, along with all of the other techniques that I mentioned, are what makes source maps at least small enough that they don't regularly crash browsers. I should point out, source maps do crash browsers. And it's not incredibly common, but as I was talking with some people about this talk, someone actually suggested that I talk about why source maps crash browsers. And I will touch on that just a tiny little bit, but basically the answer to that question is, I don't know why they crash browsers. Someone should totally research that, because I bet you there's at least a nasty bug in there, if not, the glory of making a ton of JavaScript developers' lives a little better. So I want to talk a little bit about how the mapping field actually works. We sort of designed like this prototypical source maps thing, walked you through VLQs. Now you can look at the mapping field and actually have an idea of what's going on there. So each row of the output file has 0 or more mappings associated with it. And it's interesting, too, that it can be 0. That means if you've got rows in the output file, you can completely skip over them if you want to. You don't have to represent them with the source map, which is sort of interesting from like the evil perspective. It's also kind of interesting because if you start looking at generated code, and I looked at kind of a lot of it at this point, you'll notice that lots of things put stuff in the output file that have no relation to what you coded. Things like little like polyfills and all sorts of other little bits of code that you need, but have nothing to do with foo.js or whatever it is that you were compiling. So the first thing you're going to see, and the thing that you're always going to see if you actually have a mapping, is the starting column of the output file. Generally, though, when you look at VLQs, you aren't going to see too many with just one value in them. Generally, it's going to be a number of values. You're going to see at least 4 and maybe in some cases 5 values. Values 2 through 4 are going to be an index into the sources list, the source row, and the source column, just like our example. Value 5 is an index into this names list, this thing I told you about that it seems like no one can really tell me exactly what it's used for other than maybe deobfuscating stack traces. And if you happen to know, like with certainty, why this thing exists, I'd love to hear that story, because at this point, like, all of my research has just turned up with like people saying, yeah, we thought it might be useful someday down the road. Each mapping is separated by a comma, and so you're going to see a lot of things, and this is not a valid source mapping, at least I hope not, or in a sense, I mean, I hope I haven't looked at these enough that I can just write one down, because that would depress me a little bit. But when you see something like this, that would be a source mapping, and then we're going to have a comma, and then we might have another source mapping, and so on and so forth. And then finally, each group of mappings for the row in the output file is separated by a semicolon. So at the end of this, which is row 1, we'll have a semicolon, and it'll start off with row 2. And oftentimes, you're going to see this a lot. You'll see groups of semicolons. And generally, that is the compiler basically saying, oh, yeah, there's a polyfill there. Just ignore it. It's not important. Or maybe it's someone saying, hey, there's a Bitcoin miner there. Just let it run and make money for me. Who knows? But hopefully this starts to make things make a little more sense. And when you look at a source map now, you can really say, yay, I love source maps. They are awesome, and I actually kind of understand them too. But there's just one more question I wanted to answer here, is that can I actually do evil things with source maps? Because when I originally talked with Ian about this talk, I was like, hey, I want to do evil things with source maps and then talk about it. And I was trying to figure out while I was writing this, can I really do bad things? Can I like make things happen that shouldn't happen? And clearly you can hide source code with this. Because they're enabled by default in all browsers, if your user is smart enough to at least go into the debug tools, they might not be smart enough to turn off source maps or look at the original source. They might just not even know it's a thing. And so it's pretty easy to at least trick some people into thinking, there's nothing bad going on here. This JavaScript looks fine, when in fact it could be doing really, really bad things. Also, there are big, complicated source maps. And I've talked to at least a few people, as I said, who've talked about browsers crashing when they go into debug tools. In fact, I would wager that if you've dealt a lot with really, really big projects, you've probably turned off source maps at least once or twice just to make your debug tools work a little faster, a little better. And so there's something going on here that they don't really understand. So could you do bad things with source maps? Well, if you can get someone to open the debug tools and their browser crashes, and yes, that's at least like a denial of service. It's not the best situation to be in. And so yeah, there's some stuff that you could do. I think that you'd have to definitely spend more time than I did focusing on the evil portion of source maps. My evil dial's not up high enough, and so I want to just point out some other interesting things about all of this. Some things I really didn't have time to touch on. There's a lot more out there than what I just went over. So now you know how source maps work in a basic sense. But there are these things, multi-level source maps. And again, if you started using tools with pipeline, one tool after another tool after another tool, maybe you've had experience with these things. So there are a lot of takes on how to make these things. The spec kind of mentions them, once or twice. It's not really clear on how to implement them. It's kind of like, it kind of says them. It's like, oh, maybe it would work this way, and then just hand waving, and that's it. So looking into multi-level source maps is sort of like the next level for this thing. Also, there are lots of different ways to generate source maps. As it turns out, generating source maps is actually kind of a CPU-intensive process. So as you're generating source maps, Webpack in particular has like half a dozen different settings on, do I want my source maps this way or that way? Do I want them with like extra cheese? Or, it's just like all of these settings. There's a ton of information that Webpack has, including a bunch of examples of all the different ways they can generate source maps, optimize them, make them worse, make them better. So it's definitely worth looking into that as well. I've got a couple links here, just things to the source map spec, base64 reference, VLQ reference, the VLQ library, and the VLQ decoder I mentioned. And I'm just wondering now, any questions? Yes?
These are probably just remedial questions, but if you deliver a source map and there's an error in the encoding of the source map, what happens? Does the browser just bail out and say, no, we're just going to ignore those and I'll show you the actual code? Like your actual base64 encoding segments there. So if you had something after CABD that wasn't base64 encoded but was technically a valid string, would it fail and say, I can't decode this, so this source map is invalid?
So it's interesting. The browser tries really hard to make it a valid source map, but not quite as hard as it might try to make something valid HTML, for instance. And so when you start running into problems in the way a source map is encoded, most browsers, yes, will just bail out. But there were, as recently as I think maybe 3 or 4 years ago, there were bugs in browsers where again, because this is more of a convention than a specification, some browsers expected like the identifiers and names to be unique, and then some source maps, they weren't. Right. And browsers were having all sorts of problems with that, including like exhibiting some weird behavior when that would happen. And so I think it kind of comes down to how creative is the problem that you present with the browser, and does it have a way to say, oh, nope, that's invalid, and actually bail out gracefully. This is still a really, again, I'd love to see a spec happen, because at the moment, this is still very much like something that lives in a Google Doc that everyone implements to the best that they can, and some weird stuff happens, even just between browsers. Anything else? Yes?
What governance body, you said there's no spec, right? Which I'm super surprised about, because I thought there was.
Yeah.
What governance body do you think should be in charge of getting a spec out, like TC39 or somebody else?
I mean, honestly, I'd probably, if it were me, I'd probably like to see it either be an RFC or have the W3 organize this, because I don't think it's appropriate for TC39, because source maps are being used for a lot of other things now. One of the things I didn't mention, source maps are used for CSS compilation. Source maps, we're actually getting close. I'm not sure if we're quite there yet, but source maps can be used in compiling Rust or WebAssembly as well. And so this technology, for as sort of brief and incomplete as the spec is, it's being used in lots and lots of places. And so something that is more web technology focused should probably be taking it over, is what I think. I think there's movement to try and create an RFC, but it's not exciting or glamorous, and so there hasn't been very much movement. Yes?
If I understand the spec correctly, you can have a source map that maps the full output file to the full input file. Did you see any examples of that sort of laziness?
So I guess I don't exactly know what you mean, like the whole output file to the whole input file?
Like saying start at the first column, first character of the output file, map that to the first column, first character of the input file, and just like the
So
whole
so I didn't see anything in the wild that looked like that. Most of the examples I was looking at were actually like made by like tools that were trying to be helpful. I did like handcraft some of my own source maps, and I did some strange stuff similar to that. And I will say that debugging tools start acting really funny. It just doesn't quite know what to do. And again, like this is like, if you're interested in like bugs in browsers and security and stuff like that, I think there's like a really sort of like a lot of stuff here to look at, because all of like the weird behaviors that I saw, all of the people that like I talked to and said, oh, source maps, man, those things act strange sometimes. Like there's like a lot of weird stuff in here. And so just from poor mapping all the way to like literally like, oh, your browser just crashed, sorry. Anything else? All right, well, thank you so much. Really appreciate the opportunity.
All right, time for a question. So the way this works, he'll ask a question about something that you talked about. Raise your hand and I'll call on you. The first person I see raise their hand. Don't shout out the answer because then it's hard to tell who did that first.
Okay, so should I do something like trivia or something that's actually like, you know?
Something that's a little difficult
A
to
little difficult.
remember, but you know, something that people have a chance to get right.
Okay. So, in what year were source maps originally invented?
2009.
Yep, that's right.
Was it 2009 or 2011?
It was 2009.
Okay.
They weren't released until 2011.
Oh, trick question.
Yeah,
Very cool.
yeah.
All right. All right. Thank you again, and everyone. Thanks, James, for dealing with our technology problems up here. It's like we're back in 2009. I guess.
Yeah, exactly. The dark ages.
Back in the Stone Ages. Thanks for coming. I hope you all will join us